Okay, I think it's time to start our webinar. So welcome everyone for this webinar with the topic working towards circularity in textiles. There are two different research projects behind of this webinar. So TEREX, Textile Recycling Excellence Project, which is funded by European Union Horizon Fund, and it's run by Adidas. And in that project, we actually are researching the scaling up process of how to handle textile waste when we are really scaling up the recycling practices and recycling understanding in the textile context. And the other research project behind of this webinar is Phoenix project, which is funded by the Research Council of Finland, strategic funding, and run by Aalto University. And in Phoenix project, we are studying how to do the sustainability transformation in textile and fashion sector, and of course the circular economy is actually one of those important parts that are included in our research. My name is Kirsi Niinimäki. I'm associate professor in design in Aalto University, Finland. And with me this afternoon, there are three interesting speakers. So we have Dolly Velanki from Fashion for Good Netherlands. We have Josse Gunst from Cure Technology Netherlands, and then we have Paula Sarsama from Infinite Fibre Company Finland. Just like a few words about the topic today. So probably everyone knows that we are right now really fast moving towards a circular economy. So that means new kind of understanding as well as new kind of practices, especially in textile and fashion field. So this will be a really big change for all industrial and business partners. Really big changes need to be done when we are moving from away from the linear model towards a circular one. And everyone knows that, well, these textile waste figures have been increasing in all Western countries. And in 2 years' time, when the EU regulations are then coming, that each European Union country needs to somehow handle the textile waste. So we have to collect the textile waste, we have to sort it, and then we have to put that in some kind of effective recycling path. So that will be a really big change in the industry. And first speaker today is actually Dolly. Welcome, Dolly. And Dolly will talk about how does the policy and regulation can really impact on this innovation and the change process. So thanks. Welcome, Dolly, and you can share your screen.
Thank you.
Oh, one note still. We hope that we have an active audience. So throughout the presentations, you have a chance to write your questions in the chat blocks. Please do so, and then we try to pick a couple of questions after each presentation, and then we have a little bit more longer question and answer session at the end of all presentations. But yes, Dolly, sorry, now you can start.
No problem. Well, thank you so much for having me here today. So yeah, my name is Dolly Velanki. I am an innovation associate at Fashion for Good. And Fashion for Good is also a consortium member of Textile Recycling Excellence, which is the short form TEREX, as we like to call it, which is a Horizon Europe funded project. So before we dive into all of the important topics, I wanted to mention that I'm here today to talk about policy and innovation and how that's going to support the industry in reaching towards textile circularity. And I also wanted to briefly touch upon what Fashion for Good does, who are we, to also provide you with a little bit of context as to why I will keep talking about innovation and technology. So Fashion for Good is a global innovation platform or global innovation program. We have the many connections to the industry and have the industry ecosystem from brands and retailers to manufacturers, innovators and startups, multi-stakeholder organizations, and investors. So we really try to be the convener of all these different stakeholders in various forums, whether that's pilots and projects or whether that's more strategic implementation cases and so on. So what we've been doing really well over the last 5 years is scouting and screening a lot of innovators and startups within the fashion industry. We look at innovations across the supply chain, so from raw materials to processing, end of use, recycling, sorting, and also overarching topics which are very important like transparency and traceability. So with these innovators, we choose about 10 to 12 innovators to join our program every year, and we provide them with bespoke support from investment, media, marketing, business modeling, piloting, and really working together with our partners to pilot, validate their technology, and really also support them in quantifying their environmental impact, which we know with the upcoming legislation is also becoming a very important topic. And lastly, our focus, now that we've existed for 5 years and have a good grasp of the industry and the landscape of innovative solutions, we really want to focus on scaling and adopting these winning and success stories and success players. So we want to connect these players to important and large-scale investors and financiers so that they can get the right investment to conduct the necessary R&D to develop the infrastructure and their technology. But we're also increasingly working with our manufacturing partners that are in manufacturing regions across Asia to really facilitate the integration of the innovation and technology into the supply chain where a lot of the impact is happening. And we really want to focus on amplifying the success story so the industry is aware of what technology is really, winning and which technologies are some of the ones that we stand behind. And you'll actually hear from both of two innovators today who were a part of our program, both Cure Technology and Infinited Fiber as well. And I just wanted to quickly show you some of the partners that we're working with to show some of the impact that we can have, especially when we're looking at integrating the technologies and innovation within the supply chain of these different stakeholders. So we have the likes of brands and retailers like Adidas, Inditex, PVH, Patagonia, Zalando, but also, as I said, increasing our reach in the manufacturing regions with players like Arvind, Birla Cellulose, Wellspun, Teijin, and so on, and continuously increasing our partner group. So really making sure that the innovators and startups and the identified technologies have a place to pilot, experiment, test, and then once succeeded, to really be able to implement and work together with brands, retailers, and suppliers as well. And just to quickly show some numbers and impact as to what we've done, I'm not going to spend too much time on this, but I wanted to showcase that within our program now we have supported about 173 innovators, where we've piloted around 326 different pilots and testing moments, and have about 180 implementation cases within the industry. And we've also invested into our innovators as Fashion for Good, and have supported our innovators in raising about 1.5 billion euros since they've become a part of our program. So just to show you a little bit of the impact that we've had on the startup world within sustainable fashion. And if you're ever in Amsterdam or know anyone who's going to Amsterdam, I really suggest stopping by our museum, which is in the city center of Amsterdam. And it is a very unique opportunity for you to, as consumers, learn about sustainable fashion, and also about how your choices can really support the industry and change the industry. And on top of that, you'll also learn about the different innovations that are in the sustainable fashion world, and get to interact with some of that as well. And also see some of the installations where our innovators have worked together with some of the up and coming designers, but also some of the big brand names as well. So it's very much in the center of the Amsterdam city. So if you're ever there, I really suggest to go. And it's a beautiful exhibition. And we're also changing our exhibitions every few months. And the latest exhibition was about cotton, so really knowing the intricacies of the cotton history, but also sometimes the twisted stories of the cotton industry. And so it's very interesting to also get to interact with some of the innovation firsthand. So now let me dive into one of the topics that is very close to my heart, and also a topic that I'm sure a lot of you have heard being discussed within the textiles and fashion industry. So there's a lot of regulation coming into the textiles and fashion industry. And I think one of the reasons why there's so much hype around it is because historically the fashion and textiles industry is not one that was very regulated. So there's a lot of, especially when you're looking at sustainability or circularity as a focus. So there's a lot of new regulation that's coming in this industry that is very much focused on circularity, sustainability, all of the big buzzwords that we hear. So I'm not going to dive into every single one of them, but I just wanted to show you some of the main topics that are really coming up. And they range from, improving the design and durability of products, digitizing the supply chain and product information, a lot of regulation around waste, which I'll dive into in a bit, around claims that you make on a product. So when you're claiming something is carbon neutral or something is sustainable or environmentally friendly, there's going to be a lot of scrutiny around that. There's also a lot around reporting and conducting due diligence to actually mitigate the hot impact areas that are identified in the supply chain. Also about sustainable financing opportunities, microplastics and microfibers, and a lot about chemicals, which are going to be coming up within the industry as well, so that we can really transition from hazardous chemicals to ones that are more sustainable and ones that are safer by design as well. So before I dive into the nitty-gritty of sort of the waste legislation and also how some of the projects that we're involved in are trying to tackle the topic of textile circularity, especially from an end-of-use or end-of-life perspective, I wanted to point out why is policy important when talking about innovation. So how does policy impact innovation? In a more positive lens, I think the way that policy can impact innovation is that it creates incentives. So a lot of the industry is required to meet new compliance requirements and has to change the way that they're working. So it can create incentives and maybe support schemes to advance and adopt new types of innovation, whether it's technology or whether it's new processes as well. But this is also the reason why it's creating a higher demand for these types of new tech and new processes to pop up in the industry. So it's trying to create an environment where more solutions can be founded, but also they can be funded so that they can be implemented within the industry. Lastly, one topic which I think is very close to our heart at in the projects that we're working on is also the topic around harmony and standardization in the industry. This industry is very fragmented. There's lots of different stakeholders. It's very globally spread out. So how do you bring the industry together collectively and make sure that we're working towards a textile circularity as the end goal? And that's really hard to do when everyone uses different data points, everyone uses different methodologies, when everyone even has a different definition for what circularity and sustainability means. So I think that's something that policy could potentially support, but that also really depends on how effective policy is. So there's also the flip side of that. And lastly, I think what policy is really doing at the moment is really getting some retailers, brands, manufacturers to rethink their business models. So policy is really asking, is encouraging the industry to think about new forms of sustainable ways to become profitable, to also think about degrowth principles and so on. So I think there's a lot of different business models that are popping up, but which of course need to be profitable as well. And actually the last point that I think is very important is that policy is really looking at creating more transparency in an industry where it's very untransparent, very difficult to find information, again, very fragmented. So the policy is really looking at increasing that transparency. And I think it's not just increasing transparency for the sake of transparency, but it's really so we can identify where does change need to happen. So that's also why innovation becomes very important, because once you identify where the hotspots are and where the challenges are, there's a lot of solutions out there which can be plugged in and which can be adapted. So these are some ways which policy can impact innovation and how that can then support us achieving textile circularity. So now I wanted to touch into the topic of waste. And There's a lot of policy that is coming up within the EU around textile waste, and that's because the amount of textile waste that we produce is a lot within Europe. Also, globally, there's just high amounts of textile waste being produced. One of the topics that the European Commission is very much pushing forward, or the idea is the idea of waste hierarchy. So really looking at what should we prioritize as the next high value end of life management for a product or a garment. So I think the top one is very obvious: prevention. So that's reduction. So reducing how much we produce and also reducing how much we consume. I think that one is a little bit harder to set targets on. So we're not really seeing a lot happening in terms of reduction in overproduction or reduction in consumption. But ideally, this is where the industry is moving towards. And then we also have topics such as reuse, recycling, which are two forms of other end-of-use management options, which are being prioritized by the European Commission and also by the industry, prioritizing that over topics like waste to energy, landfilling, incineration. So to really push the idea of reuse and recycling, we're seeing a lot of different regulation popping up. So there's the extended producer responsibility, which is really about creating accountability and responsibility to the players that are putting products on the market to take back what they are placing on the market once it's disposed and giving it a new life, whether it's the form in reuse or whether it's through regenerating it through a recycling process and entering it back into the market. There's also the topic of waste shipment. As I said, there's a lot of textile waste that's being produced by European countries, but also American. So a lot of the global north is producing a lot of textile waste, which often gets shipped out to the global south to then end up in landfills or end up in incineration situations. So there's also going to be increased scrutiny around what gets shipped out and for what purpose. There's also the separate waste collection that's coming up, which means that every member state in the European Union needs to set up very efficient, or ideally very efficient, infrastructure to increase the collection of textiles. And this means that the amount of textiles being collected is going to increase. So that's also why it's really important that there's infrastructure to actually deal with that, and that recyclers and innovators such as Cure Technology and Infinited Fibre are become very important because they are potential solutions to how to deal with the increasing amount of textile waste. Then there's also criteria and more targets on how to prepare items for reuse and recycling, enforcing polluter pays principle, going back to that idea of actually holding players accountable for how much waste they're producing. And then lastly, banning the destruction of unsold goods, which is, again, an obvious one. What can you do with goods that are not being sold? If they don't have resale potential, where does it end up? I think there's two very specific points or steps that can help achieve textile circularity. One is to develop the infrastructure so that we can more efficiently collect textiles, and we also need to build sorting capacity so that once these amount of textiles are being collected, there's an actual process to properly and efficiently sort the collected textiles and then direct them to the best end of use scenario, but then also preparing these textiles for reuse and recycling. And again, going back to my main point of the fact that there's more innovation and technology that needs to be developed. There's a lot of solutions out there that can support in reaching textile circularity, that can better sort, that can better prepare textiles for recycling, and that can do the recycling. So there needs to be increased R&D around this and also investments. But beyond that, beyond investing and testing and piloting, there's a lot that needs to be done from the industry itself with these innovators and with these startups. We need to go beyond and set up these offtake agreements and these long-term commitments between the industry and between the technology providers so that there is supply and demand, secured, and that this textile circularity can actually be viable from a profitability and a business standpoint as well. I want to quickly touch upon two projects that we're working on that really try to show the potential for textile circularity. One of that project is called the Sorting for Circularity project, and that is a project series or framework that we developed at Fashion for Good. It originally launched in Europe and is now also taking place in India and in the US. And within this project, we really wanted to show that there's more harmony that needs to be created between the sorting industry and the recycling industry. And we wanted to show that if sorters sorted based on composition and color, that there is a business case to sort that way, because textile recycling is also scaling. So we really wanted to show the business case around it. As I said, I think if you don't prove the profitability and the viability of a business case for different stakeholders, the idea of textile circularity wouldn't be sustainable. So we went into some of the biggest sorting facilities in 6 different European regions, and we analyzed the material composition, color, what disruptors it has, and so on, of the low value textiles. So really looking at ones that are usually exported or ones that are considered fit for downcycling, the wiper industry, for other forms of recycling, and so on. And we analyzed the material composition of these items using handheld near-infrared scanners. So without going into too much detail, what we found that is a good news, I guess, is that there is a business case to sort for circularity, to sort based on composition and color. We found that in total, there's 494,000 tons of low-value textiles that can be directed to textile recycling, and that includes both the mechanical and the chemical recycling technologies. And that there is indeed a business case for doing this, because this can generate about 74 million euros per year for the sorting industry if created this way. And then there's a lot of other stakeholders which can also capitalize on this feedstock if the sorting is actually done efficiently and for specific end-of-use destinations. Another project that we are involved in is called T-Rex. As I mentioned, we are part of the Horizon Europe project, and this project is really focused on that, both the technology angle, but really that infrastructure angle as well. So we really want to show this textile circularity process by including the different stakeholders across the circular textile value chain. So from waste disposal to collection to sorting to recycling to the spinners to manufacturing, and then again back into use. So we're really trying to bring in all these important players together to see how we can work together, where infrastructure and technology needs to be further developed and where investments need to be made, and also just really understanding, is there a blueprint that we can develop for the EU? And if so, what are the different nuances that need to happen across different cultures within the EU? And yeah, so this is a very important project, and it's going to run up until 2025. So very curious, and I think a very important project for the industry in developing the right infrastructure, both from a digital angle and a physical angle as well. And I just wanted to end on speaking about what's next. So I think it's very obvious, and I think one of the things that the T-Rex project is also trying to tackle is that a lot of different parts of the supply chain need to work together and need to collaborate. So that is a very important thing, and I think that's why these consortium style projects are very, very important. And my next point is, again, back to that business viability and profitability. I think within these projects and within all of these different piloting, experimentation, it's really important to identify whether there is a business case and what the business case is for investing and for implementing a certain type of circular technology. Because if that's not proven, then I think it's very difficult to get the stakeholders on board. Another obvious one is the changing of consumption patterns for both the industry, so also not just consumer end, how much they're buying, what they're buying, but I think also the industry and sort of what resources are being consumed and what's being placed on the market. Again, back to investing in further developing both technologies and infrastructure, and also brands further committing to adopting circular design practices. And I think they can learn a lot from all these different projects that are running and from all the different players like the recyclers, like sorters, to really understand how to design so that products are, after being disposed, can re-enter back into the market as well. I think policymakers and government and municipalities also play a huge role, because they really need to play a big role in setting up infrastructure, building the capacity for sorting, and also for giving schemes and support to innovators and technologies to flourish within the European regions. And lastly, I think I've said the word textile waste a lot, and I think waste definitely has a negative connotation sometimes, but I think it's really important to redefine how we look at waste and really looking at it as a resource or a feedstock for new products as well. So we know that the eco-design law will look at setting targets for how much recycled content to include in products. So I think it's really important to redefine and reclassify how we look at waste so that we can really support in creating that market for recycled content as well. So that is all from me. Thank you so much for having me. And yeah, very curious to see if there's any specific questions I can answer now or later.
Yes, thanks, Dolly. I think that to keep up the timetable, so let's keep the questions at the end. I think that there are some questions for you, but we can answer those at the end of the presentation. So please, can you stop sharing your screen so then we can actually invite Josse Kunst to come and share his screen. And Josse is from Q Technology. So please, Josse, it's your turn. We can't hear you.
Second, I had to pull up the presentation and let me share my screen. Good afternoon, everybody. Thank you all for listening. And I see there's a large crowd, and I'll see if I can help with sticking to the timeline. I think that will be possible. So a real pleasure today to highlight, at least from our point of view, Cure Technology and my own view on how we can make a real step in chemical recycling of synthetic fibers. Very proud member also of the T-Rex project. I think it's a great example of really building a dream team across the value chain where we can really make a big step in not just talking, but really doing. And we're very pleased with the European Union, of course, for funding this. And I have to say, I think the European Union has a real chance to lead this transition in the world. And representing still about 1/3 of the turnover in the world in fashion. It's a very interesting position, and brands will follow what happens in the EU in terms of regulation very carefully. Very brief background of myself. I'm a chemical engineer by training, completed an MBA after that. I've lived and worked around the world, and I've been in fiber-related business since 1999. A couple of examples where I've been working on has been the Circularity initiative of Royal DSM, where I've been leading the Niaga initiative, in which Niaga is the word again written the other way around, where we really looked at design for recycling. I'm currently active in a couple of different initiatives where we look at various stages of circularity. On the one hand, consultancy, on the other hand, can be bio-based. With Arapaha, Textile Forever will actually prepare textile waste so that it can be fed into chemical recycling. And Cure Technology, which is member of the T-Rex project, is of course trying to develop an economic and low carbon footprint technology to recycle polyester. Putting that into perspective from the EU, the EU has a very clear and very ambitious sustainable and circular textile strategy. The strategy has been announced already a while ago. And slowly the key elements are becoming more clear. Dolly already made a good remark on several of the policies and legislations that come up. Some of them are very crucial. But if you look at it, it has the potential for solving the issue of 5 billion kilograms or 5 million tons of clothing being wasted just in the EU every year. Now, if you just think that's 12 kilos per person, it doesn't sound like too much, but 5 billion kilos, I think it's worth putting effort on. And what you also see is that that will create a new set of labor pool opportunities in Europe. Now, I spoke once to Jyrki Katainen, former Prime Minister of Finland, and he said, circular economy is two words. It's circular, sure, but it's also economy. It creates new jobs. And especially jobs locally in Europe, which I think is a very crucial part of the strategy as well. The number on the right, you can judge it as an optimist or a pessimist. Only 1% of clothing is currently recycled. I see a huge opportunity there to in fact make rapid progression towards first 10% and then rapidly further. And I'm very confident that this will become the norm. Now, couple of other key factors from the EU that for me were quite highlighting the importance. So just a couple, 1.5 million people employed in this sector, 162 billion turnover in Europe in fashion. Still 63% increase of consumption of clothing. So we can start to think about 1% recycling and solve that to 10% or 50 or 90. At the same time, the volume is growing as well. So if you think about the capacity we need for recycling, for collection, for sorting, that is crazy almost to think about. Huge opportunity to do good for the planet, I think. Now, 6 key elements in the European strategy that are linked to the T-REX projects in one way or the other and to the work we do at Cure. So number one, very, very important, design requirements, the eco-design regulations. We spend a lot of time at Cure right now in the stage where we are to help companies look at their bill of materials, look at their designs, and to understand what the material choices they make have as an impact on final recyclability. I'll come back on that a little bit later. I'm excited about the mandatory digital product passport. That's also a work stream in the T-REX project where we look at the gaps in that, but I'm really confident that digital information will make it easier to close the gap, because in the end, knowing the composition of clothing as a consumer is important, knowing where it comes from is important, knowing how it has been produced, but also for the recycler, it is crucial to understand the chemical construction so that they can adapt their recycling techniques. I think we all are bombarded with information, so having clarity that claims are verifiable and true and really lead us to a better way forward is very important. So the Green Claims Initiative, I think, is much needed. Microfibers, number 4, clear concern for all the consumers in Europe and around the world, where there's a lot of action going on. Very important, and also very important, I think, to look at in recycling techniques and in the whole collection sphere, that we make that situation, in fact, better rather than worse. And I think there's a real opportunity for that. Number 5, crucial, was recently some further announcements on that from the European Union. There will be a harmonized EU-wide extended producer responsibility that will include also mandatory recycled content for fashion. And we've seen from the packaging industry that has really changed the game. Because of that, people need recycled content to make fibers and to make textiles. And you see that therefore there's a healthy economy starting for recycled products. So I'm very, very hopeful that that will set the scene, that will solve a lot of the current economic challenges that are out there. Now, nevertheless, the Cure technology plant, for instance, is 5 minutes from the German border. So understanding how to have cross-transport of waste across borders, the waste frame directive, and when is something end of waste and becomes a feedstock is also very important and under discussion, under debate. And I hope the EU will make the right choices there to, on the one hand, make transport easy, on the other hand, avoid that we ship away our waste and our problems to Asia and Africa and the Atacama Desert and wherever we have dumped our clothing so far. So interesting challenge for the EU to there find the right tone so that on the one hand, they can facilitate the recycling locally. On the other hand, we avoid exporting our waste problem. Now, being a big fan of recycling, I have to also be humble. It is only action number 7 in this hierarchy of waste. McKinsey made a good overview. There are many different versions. So while I will talk to you about recycling, for sure, refusal of consumption and reduction of consumption are really, really needed to stem the flow of material. If we still predict that 63% of growth of volume will come, it's almost impossible to fight our way out of that just with recycling. It's not possible. So we need to find a way to make clothing last longer, convince consumers to buy less. That's, I think, a much bigger challenge for the fashion industry than the material transition. The recycling will be economic at some point. But dealing with a market where we need to, in fact, tell people, like Patagonia did in years back, don't buy this product, that's going to be much more difficult. I'm also excited, and I think France is leading the way there about the right and the responsibility to repair. In France, consumers have the right that products need to be made in such a way that they can be repaired. And I see a lot of good initiative also in clothing, where repair becomes the norm. And I think that's not necessarily always easy. I've personally, my experience is that getting that done with European cost structures makes that often the repair is more expensive than buying new clothing. But I think fundamentally we need to keep clothing in the loop in good condition as long as possible. Having said that, at Cure, of course, at some point, we are very willing to receive clothing that is no longer valid to be used and recycle it back to new materials. Having said that, and that's really a reach out to all the designers, that problem will only be solvable if we start with making the right choices for materials in the end. So understand what the impact of your design is on the end of life strategy is really crucial. Now, a couple of pictures on volume and types of fibers. On the left, an interesting story from McKinsey, where they showed that current fiber-to-fiber recycling is less than 1%. 2020 number, 7 billion kilos of textile waste. As you can see, numbers vary a little bit, but huge amount of volume. They project 1 billion kilograms extra by 2030 and a massive growth from less than 1% to 26% in an upcase scenario for fiber-to-fiber recycling, and also fiber to not fiber recycling included. I hope the reuse part will grow fast and that we can in fact come to more than 80% of clothing not being thrown away or incinerated, but being reused in a proper way. Now, if you then look at what kind of fibers, synthetic fibers, are in use, it's very clear that polyester is by far the dominant fiber, and in fact the only one that's really growing. And that's due to its good performance, its low cost, and the fact that you can combine it very well with cotton, and especially if you include polycotton, you really capture 80–90% of the key fiber production. So from a recycling point of view, to focus on that is crucial, because unless we solve polyester, we basically cannot be circular in textile to textile. There is a challenge with that other 10% of products, of course, especially if you mix it with polyester, but I'll touch base on that a little later on in the presentation. Now, if you look at recycling of textile, there is a very, very wide variety of options, both mechanically as well as chemically. And Refashion from France has a beautiful overview of that. I was very intrigued by seeing all these routes so clearly, where you see a massive amount of different machines. What we are looking at today, and I don't think you can see my mouse, is with top left corner, let's say 11 o'clock, where we go in the end to depolymerization, to either monomers or oligomers in our case, and back to new yarns. That definitely, this picture also shows that there will be a very natural hierarchy established in Europe at some point, where depending on the location, depending on the quality, depending on the quantity, people have a choice. And I'm very pleased with that, because this will give a healthy competition for feedstock, where it will find its way depending on the economy and on the capabilities. Now, while we talk about polyester, I think it's also good to share the case of EcoNyl of Aquafil. They have proven that with nylon 6, it is already possible. They capture fishing nets from the ocean. They collect the yarn waste from their carpet customers. They collect composites with nylon in it from their engineering plastics customers. And back in Slovenia, where they have their chemical recycling plant, they have a full-scale 42 kiloton depolymerization unit, where they turn the nylon 6 waste back into caprolactam. That caprolactam gets shipped back to their spinning plants, amongst others in Italy, Lago di Garda, where they turn it back into nylon, which they brand as EcoNyl. For me, I think Giulio Bonazzi, the CEO of Aquafil, there has done an amazing job to show that it can be done through stamina, through perseverance. Also, he has turned it really into a story, to a brand where large companies and large brands like Prada, like all kind of companies that have a name now want to join EcoNyl to tell that story. And I think that's very, very encouraging for the polyester folks, because it shows it is possible. Now, as a result, also one of the team members of T-Rex, BASF, is looking at nylon 6 recycling. Vibrant, part of the Chinese company Hysun, is looking at it. Toray. So it has inspired success, and I think that is really good to see. especially if you combine it later with larger collection and sorting rates. Yeah, so it can be done. It's really hopeful. Now, if you look at polyester, the chemistry is of course different from polyamide. However, it is also a reversible polymer. Yeah, there's a couple of reversible polymers out there like PA6, like PLA, like polyester, that basically when you build up the polymer, you make it such that the chemical bond is weak enough to break it down again and build it back up. Yeah, so if you think in Lego blocks, you can think of polyester as a chain of 100 blocks. You can break it down back again to 1 or to 5 or to 10 and build it back up again. And that is a unique opportunity with these reversible polymers. I'm therefore convinced that plastics like polyester, like PA6, will demand a position in the market similar to glass, paper, aluminium, because they are in fact really good circular building materials. In that sense, much more so than polyolefins, where you really need to crack them all the way back to the monomers, and it costs a lot of energy. Now, having said that, polyesters, first and foremost, is a family. We talk a lot about PET, and that represents the majority. But there's also bicomponent polyesters, there's PTT, there's PBT, partly bio-based often also. There's PEF coming up. There, PLA in a way is a polycondensate or polyester as well. We are looking here predominantly at PET with Cure, but we can handle also quite uniquely the other polyesters. And we do that by breaking it down to a oligomer, 5 to 8 monomers in a row in a process called partial glycolysis. I'll explain a little further why we've chosen that route. Now, there's quite a few players doing batch-wise glycolysis around the world as well, and then you end up with a molecule called PHET, which is the monomer of polyester. There's other ways where you can break down by adding some methanol, then you end up with a methanolysis process. You end up with DMT as the building block. Easier for purification in the recycling. However, 90% plus of the current polyester plants do not use DMT anymore as a feedstock. So it will require substantial additional investments to go to that route. Because most polyester plants are currently using PTA, the lowest molecule, together with ethylene glycol as a building block. Now, to reach PTA, you have to do hydrolysis, so add water, or use enzymes. Now, one of the reasons why at Cure we chose partial glycolysis is that I've put them in the order of the potential energy of each molecule. So the further you go down, the more energy you need to put in to break it down. And the more you need to put back in to go all the way back up to polyester. So what we found out and what we patented at Cure is that if you break down polyester for 80%, so to the oligomer, you only use 20% of the energy. That last bit of breaking down, going down to BHET, DMT, or PTA costs most of the energy. So we found a way to dramatically reduce the energy use and dramatically reduce the carbon footprint. It comes with a downside that you need to purify small polymers, which is more difficult than monomers, but it's doable. And we are convinced we can therefore create a process that is uniquely cost competitive. Give you an overview of that. So there's a lot happening in polyester field. Mechanical recycling of polyester is already very common in bottles, in packaging. Starts to reach its limits there a little bit because now bottles are recycled so much that it becomes more opaque, the rPET, and yellowish. So there's a clear need to be able to refresh the stream of mechanically recycled polyester back with chemical recycling. Mechanical recycling of textiles, it will take a small place in the market. We are referring here to thermomechanical, so melting the textiles. But due to all the additives into textiles, it's very limited in feedstock what you can use. But I can imagine for some post-industrial waste, even sorted by color, thermomechanical will be the cheapest in terms of investment and also probably lowest in running costs and the best carbon footprint. Now, for packaging, flake to resin can be used, not relevant for textile, to be honest. And at Cure, we do what is called partial glycolysis. And we have the ambition, therefore, to be the cost leader in the molecular or chemical recycling techniques. As said, quite a few companies around the world looking at glycolysis. There's many more, in fact, than the ones mentioned here. Methanolysis, interestingly, also large chemical companies like Eastman picking up the initiative there. a beautiful company in Switzerland and Italy, Green, having announced also a plan now in Spain going forward. And Carbios very active in France using enzymes to break down. This is the ranking how we see it in terms of investment levels, energy costs, and carbon footprint. But of course, feel free to ask them themselves. And luckily, we see them more as friends in the business because there is so much variety in waste that each of these technologies will have their own sensitivities in what they can handle. So they may have slightly higher conversion costs, but then if they can be more robust in what they can handle, it could well be still worth the effort. So I think there will be clearly all these technologies coexisting next to each other, finding their own best slot in terms of feedstock and outlet. Having said that, so there's a very welcome, I think, competitive field emerging, with almost everybody in the stage of nearing towards commerciality, but not yet in a commercial stage or even doubling capacity or tripling capacity, with potentially the exception of Jiaran in China, which was your former Tianjin plant. So good news also, initiatives in Europe, in America, in Australia even. So there's a lot going on, a lot bubbling. So in that sense, brands will have a choice and will have an ability to establish for themselves that the economy of recycling is competitive. If there would only be one leading technology fully protected by patents and you can't move around it, it's much more difficult to assess that it is the right economy. So I think this is a very healthy situation. Now, what we try to do at Cure is to be really focused on making all our design decisions for our technology on carbon footprint. And of course, use of toxic materials to avoid it. If you look in this graph, what you'll see is virgin polyester has a carbon footprint of about 2.2 ton CO2 per ton PET, or kilo CO2 per kilo PET. And at Cure, we will move directly to renewable energy and be able to reduce the carbon footprint by 88%, as you can see here. These are peer-reviewed LCA numbers that under NDAs we're more than happy to share. We've worked on this out of the T-Rex project also closely with Adidas, and another project team member, Quantis in Switzerland, had reviewed it. The LCA has been set up by CE Delft in the Netherlands, and includes also data from a collecting partner we have in the Netherlands called Symphony. To be fair, it's difficult to compare exact LCAs unless they're made with the same assumptions, but we're more than happy to at least go with people through our assumptions and share what we have done. Bottom line, the reason why we are double or triple as good as other technologies in carbon footprint is that we only break down for 80%, and as we shared, that only costs 20% of the energy. But we also don't have to cool down a monomer that is produced and then ship it to a polyester plant. We keep the energy in the process. We keep the oligomers warm and directly feed them in the repolymerization. And in that stage, you basically skip the whole first part of the polymerization, and therefore you save a lot of energy there as well. If you look at investment, also there, a radically different picture between our technology and others, where because we only break down for 80%, we don't need a catalyst. We can do it in small continuous equipment. And that gives us the ability to have only 1/3 of the capex per ton produced, even at small plant sizes. Yeah, so we are now looking at building a 25 kiloton plant, should be operational in 2025. And it has only 1/3 of the depreciation compared to other technologies, while the other technologies, even at larger scale, don't really seem to have a scale advantage. So our dream is that we can build a lot of small plants close to where the waste is. Yeah, that also helps, of course, with the waste frame directive. Cross-border transport is not easy. So if you can turn it from waste into new products, it's very easy to avoid all these hassles with cross-border transport. Now, let's see how this works, but it creates a different future for the chemical industry, where large plants like the ones that Eastman have announced typically have to be built close to the sea or a river. Cure Technology, you probably build close to a big city where waste is collected. We are excited to at least challenge that theory and prove that that is possible. What we do now is work closely. We've worked with over 400 companies A lot of them in textile, in fact, where we look at their bill of materials of products and under contract research, so basically cost-based research, we classify their products in 4 categories where we say this is fully compatible with our technology, limited compatibility, low or not compatible. The first 3 categories mean that a polyester comes out that can be sold. All the way on the left, I would say, classifies as monomaterial design. The second one, there are substantial amounts of elastane or other components in it, so you lose quite some mass. The third category, really polycotton is in there, and that means that you have, let's say, 30 to 60% of other components in textile. And unless you can recover them economically, and I'm sure the next presenter of Infinited Fiber will talk a lot about cellulosics, it cannot be economic. So you really have to add additional processing step and partnerships, not only for polyester, but also, for instance, for cotton. There's still a category of non-compatible. This is, of course, clearly related to our technology, and that category can be different from others. But we see, for instance, PVC contamination, at the moment still nylon contamination also being quite critical to be able to make a proper polyester at the end. Behind this, we're setting up very standardized cure test methods and also clear test reports for each of the individual contaminants. That's a work in progress, but we are excited to have a long-term relation with Adidas where we work this out. Blends, I didn't talk a lot about it yet, but clearly crucial in polyester. Yeah, so polycotton, as I said, will require 2 technologies, combining them together. In general, for the designers out there in this presentation, if you do not have to use different materials, don't do it. The adagium in recycling is don't mix what you can't fix. Here nicely presented also by a beautiful consultancy company in the Netherlands, Serious Business. The key blends that I think are relevant to solve textile to textile recycling is any combination with elastane and any combination with cotton. Now, with cotton, we are at Cure partnering with several different players and selecting which technology not only is most effective in removing the cotton, but also in turning that removed cotton back into new cellulosic fiber, of course. And then we always look at the investment levels per ton, the operational cost per ton, the carbon footprint, and the effectiveness of cleaning. We're convinced that the cotton part can be solved. In fact, there are licenses available from technologies where at least it can be done. We're not yet happy with the carbon footprint of those technologies, so we're still trying to look at that. The other elephant in the room, I think, is elastane, and especially with COVID and casual clothing going up, the amount of elastane being used is going up. Really challenge designers there to avoid it if you can, but it is a lazy molecule for designers because it makes tolerances of clothing easier. But I'm excited to share that at least at Cure, we have developed now a proprietary technology that can remove elastane up to very high amounts and in such a way that the elastane can be recovered and sent to a chemical recycling of the polyurethane part. This is proven now at lab scale very robustly, and we're currently looking for the equipment where we can scale it up. That is a necessary step before we really raise the flag and say open for business. But we are excited about the fact that we can do this because when we started the T-Rex project, we did not yet have that capability. So going forward, what do we at Cure see as the key challenges? First, top left, there is still a lot of money necessary to build plants, to scale up. I have to say there is a reasonably healthy climate now in Europe for support. But also we will, as consumers, as brands, need to support the economy because initially small recycling plants that are just starting can never compete with completely economized large-scale plants in Asia. Yeah, so I hope, frankly, that the extended producer responsibilities in the EU and the minimum recycled content will create a demand that is healthy, where it can be economic for everybody in the chain. Mind you, consequence will be clothing will be more expensive in the future. There's no doubt that I have. It moves us to the middle, the consumer, in this case, buying food, not clothing. However, we need to reduce our consumption. We need to make conscious choices for the most sustainable clothing. And I hope that with all the mandatory issues that the EU will roll out, this will improve a lot. Third one, we need to think circular in teams, no longer in linear and squeezing out everything from your suppliers and charging the highest to your consumer, because ultimately your consumers are now your suppliers again. Bottom left, regulation, a lot going on. I think there the amount of initiatives is certainly not my concern. My concern is only that the EU doesn't make the wrong choices. And especially in the packaging industry, we sometimes see that they can run too fast and demand things that are impractical to implement. So let's see where that goes. Bottom middle, still some breakthroughs through in technology. I think especially the best technologies for polycotton are still to be reviewed. But ultimately, I think it is hugely motivational for all of us to really have this impact and do something great. And with that, I close my presentation.
Thank you, Josse. This was really, really informative. Thanks very much. There's one question for you in the chat. Perhaps you can answer it there, so that we give now the floor to Paula. Paula, please share your screen and you can. Everyone can
actually. Shall I answer that one or not?
Yeah, you can write that in the chat box. So we are a little bit late from the timetable. So let's give the screen to Paula. Paula, please.
Yes, hello everybody. Just a moment. I will start sharing my screen here. Okay, can you see it now?
Yes, we can see it.
Okay, thank you. Yes, thank you to Kirsi for inviting me. This is really nice to be here to speak about a bit of a different perspective to recycling textiles. We're speaking of cellulosics, more of cotton. I have probably some of the same ideas and opinions and topics as Josse had, so I'm going to maybe try to jump over some of the things to catch up a bit of the schedule. But now you already have a good overview about the chemical recycling field. But what I'm going to talk about today is the chemical recycling of cotton-rich textiles. So that's where we act as a company. So I'm representing the Infinited Fibre company. And we are a Finnish startup company working with chemical recycling of cotton. So I would say cotton-rich textiles. So basically, what we're doing when you speak of chemical recycling of cotton-rich textiles is that we use chemical processes to break down these existing fibers to either a polymer or a monomer level. And through some of these different pulping processes, cotton can be recycled to a pulp, which resembles dissolving wood pulp. And then this can be used to create then the man-made cellulose fibers. We speak of MMCF generally. However, chemical recycling as such, it requires more processing, more equipment, more energy than, for example, mechanical recycling. But these are kind of very different streams when we think of it. So both of these processes have their own place on the market and on demands. So we all know there's already existing mechanical recycling of cotton, but the challenge with mechanical recycling is that the fiber length breaks down during these processes. So the quality of mechanically recycled cotton isn't as high as virgin cotton. However, with chemical recycling processes, we can create very high quality, high value fibers with values resembling virgin fibers or even going over those. So currently, chemical recycling of textiles is mainly done at pilot level. But for example, our company is working on pilot level. And there are several companies working already on pilot level and kind of transferring now to industrial production levels. So this is a field that is drastically growing currently, and there's a lot of companies working in this field. And here below you can see that there's we as Infinited Fibre are one. Then we have from our neighbors, Sweden, we have Södra and Renewcell. Lensing is also European. And then we have from the States, there's Evernew. So these are just examples of companies really pushing through right now in this field. And how we see it also, as Josse said, is that we don't see that these are like competitors. We see them more as collaborators. There's really a need to kind of collaboratively push this technology area through. There's so much demand on the market currently that there's room for everybody and use for different kinds of waste streams. So just very shortly about our company so that you understand a bit more where we're coming from. So we are a startup company founded in 2016, currently about 75 employees. We're growing very quickly right now, and it's mainly due to the fact that we are planning our first commercial scale factory to start commercial production in 2026. And this requires immense amounts of work from us. So currently we are working with 2 pilot sites with a production rate of about 10 tons per year. And the idea is to move to this 30,000 tons per year through our new factory. How our process works, I won't go into very heavy details, but basically what we start is with a cellulose-based raw material. So we can use any kind of cellulose-based waste stream, such as cotton-rich textiles, cardboard, paper, or wheat straw. But right now we are focusing on textile waste because we see that as a stream which is problematic in the world currently. So there's other use for cardboard and paper and wheat straw right now, but those are options for the future. But right now we are focusing on textile waste. The raw material goes first through this pre-processing phase where we remove things like the dyes, polyester, elastane. There's certain amounts we can remove. Currently, we prefer using a raw material with a minimum of 88% cotton. And this 12% can then contain different kinds of impurities that are removed in this phase. After that, we have this pure cellulose, which goes through then our sort of secret process, which is the carbamation phase. And here the cellulose reacts with the urea and it forms a very stable dissolvable cellulose carbamate powder, which is this number 3 here. It's just like a brown powder. Actually, you can see some in my background of the brown spots are carbamate. This can be transferred as such because it's a carbamate or it's a stable carbamate powder, and also different feedstocks can be mixed at this stage. So if you have you can use different starting materials, and this carbamate is still the same kind of powder. After this, it's dissolved and it turns into a liquid, and the last impurities are filtered out, and then it goes through a wet spinning process, and it leaves our factory as cut filament staple fibers. And from there on, it goes on into the conventional textile manufacturing supply chain. And how we work is that we work directly with textile brands, and they use their existing supply chain sort of forward from here. And the goal is, of course, that we produce a very high quality cellulose carbamate fiber, which we call in Finna. It's a trademark, and we hope that these garments made from Infinna will have a very long lifespan, and they won't be recycled right away. But when they are, they can be recycled as part of the cotton waste streams. So this is Infinna. So it's born from textile waste. It feels a lot like cotton, and it's really an alternative to virgin materials like cotton, viscose, or polyester, even in some cases, depending on the application. Because it's cellulose, it's biodegradable, it doesn't emit any microplastics, it only contains natural ingredients, and it saves immense amounts of water compared to cotton. Well, then a bit about the reality of working in this kind of emerging field. So, because I think this is very important now with a lot of companies working from trying to go from pilot scale to industrial scale. So there are certain challenges and demands for scaling up. Of course, we have here sort of as an engineering company, and as an engineer, I always love speaking about technology development, that this is continuous, it's non-ending. This requires constant R&D, it requires constant investments. And we see that this is really a challenge for many of these companies going from pilot scale to industrial scale, is that the required investments are very, very large. And if you're a startup company with no corporate background, for example, existing, then that means that you have to find the investments elsewhere. Now with the EU really pushing towards the green transition, there's a lot of different supports available from the EU, but we really see that this financial support from society, whether it's grants, loans, or tax benefits, this is essential for the green transition. Technology development as such, it's very different when you speak of doing it in a conventional linear system or in the circular economy. In linear systems, it's more easy to kind of stay in your own sandbox and just do the development on your own. Whereas when we move to circular ecosystems, true collaboration, open innovation, transparency, these are things that are essential, because kind of the same, what goes around comes around. So this is very important for companies to start learning how to work in these new ecosystems. Also, technology development, it can't be done by engineers alone anymore. So we have to learn this multidisciplinary way of working and understanding sort of different stakeholders in the value chain. One of the big challenges right now is the missing machinery, or I'd say not optimized machinery for separation and fiber and identification. And they have their limitations, and there's a lack of a unified way to sort. So when this exists at some point, all processes will be much more efficient and the feedstocks will be more consistent, and we can make better use of current technologies. Well, whatever kind of technology you have, even if it's a perfect technology, there's really no point in a technology alone if it's not part of existing, or if it's not part of an ecosystem or circular value chain at the moment. So if you have a technology, you have to find your place in the ecosystem, and you have to find the right partners and the right network to work around it. And as I said, we have to think in a completely new way. Companies have to start thinking of collaboration instead of competition. So there's a lot of room on the market and need for different technologies and materials using different fractions of post-consumer waste. And we see as a company that there's no point that everybody tries to tackle these problems alone. For example, these identification problems or something, that really we should try to work through these obstacles together. A company also needs to start understanding large entities. It's not enough to know your own market and your own sort of competence area. Understanding the whole ecosystem and how it works is important. So you have to think of consumer behavior, post-consumer market data, feedstock availability, production flows, and disposal alternatives. Not to even mention legislation, which Jose presented earlier. Also, designing for circularity is essential, and it has to be kept in mind at every step of the value chain. One of the ways we've sort of tackled these problems related to feedstock is that we aim for true collaboration with sorters and collectors. So since textile waste, it's very heterogeneous as a material, and these sorting technologies are quite non-efficient. So what we want to do is collaborate with these sorting and collecting companies to create a dialogue that we can improve the way of working with them, that we give them the right specifications, that they understand what we need and why we need it, and sort of we understand the challenges they're facing. So frequent testing and develop the sorting process is a way of working together with them. So they send us samples and we give feedback, and they might adjust the sorting system in a way. And then this can be then followed up in the final quality of the recycled fiber. And of course, this is not something that happens very quickly. So we prefer long-term cooperation with sorting companies, and we really see that as a beneficial way of working. So this is just an example of, for example, the feedstock that we prefer for production of Infinna currently. So we are looking for high volume feedstock cooperation, meaning 5,000 to 10,000 a year. These negotiations ongoing are for our flagship factory starting in a few years. And we can use all textile types, structures, and colors, but they have to have this minimum of 88% cotton and maximum 12% of other materials. We need to have monolayers, and textiles must be dry. What are no-nos completely are dirty textiles, plastic prints, like extra pieces on them, like price tags, packaging, and such. And the textile waste that's coming in right now these days, it's mainly pretty old textiles, so you can't really see designing for circularity in this current feedstock. But we hope that on the long term, this will change, so that clothing designed now is actually designed for circularity, so that when it finally reaches the end of life, that it will be easily recyclable. Another thing we have to remember is that circular economy as such, it won't pull through if it's not profitable. So we have to find profitable circular business models. And this means that each of the stakeholders in the circular ecosystem has to be able to make a profit. So we have to ensure the financial viability of all the players in the ecosystem. We have to constantly calculate the cost accumulation along the value chain, because it goes around and round. So it's not like the effect of one cost and ends at the next gate, but it follows through the value chain. And these are, of course, questions about pricing of the textile waste. It's easy to think that textile waste is free, but collecting and sorting also needs to be profitable, because it's a lot of labor work currently. So it's not free of cost, and also collecting and sorting companies need to be able to make business. Companies such as us, developing these actual technologies, scaling up, we require high investments, and this is something that is challenging when you're speaking of hundreds of millions of euros. And then all of these circular business models, they lean on this open collaboration and circular innovation, open communication, and working throughout the value chain. But we all believe, we wouldn't be here otherwise, we believe in this, we believe this will be happening, and really trying to go forefront with this, because there is a very strong demand on the market, and that urges us to build more supply capacity and scaling up to industrial level. So this is how we are answering this question. And this is the world's first cellulose carbamide factory in the making. We are building our first industrial level plant in Kemi, Finland, which is in northern Finland. It's being built at a discontinued paper plant. So this means that there was the existing infrastructure available for us. We can use the water systems, electrical systems, everything. It's much easier with all environmental permits because they've already been thought of beforehand. Of course, we have to do our permitting work ourselves, but there's existing partners. And what's most important is that this paper mill, when it was discontinued, there's of course a lot of unemployment. And now there is very highly skilled, qualified employment or employees on the market in that area. And our factory will create approximately 270 new jobs for this area. So this is direct jobs, and then probably double indirect when you think of all these building phases and all other support actions. And we expect the factory to kick in with commercial deliveries in 2026. We already have multi-year Infinna fiber sales agreements in place with several leading companies, fashion companies, for the first 5 years of production. So we have sold really well already beforehand. And this flagship factory with its capacity of 30,000 metric tons per year is only the first stepping stone to scaling up. So this is still quite a small textile fiber factory if we compare to large viscose factories. But this is something that we need as a first step, and then after that we plan on scaling up outside Finland, outside Europe. So thank you. That was all from my side, and I'll leave the floor to Kirsi.
Thank you, Paula. This was really, really nice. And also a good example that you can also recycle factory premises as well as partly the infrastructure. Can you, Paula, stop sharing so it's easier to see the speakers, and please open your camera, Paula, Josse and Dolly, so we can have a short discussion and question and answer session at the end. Very shortly summarizing that, I think that this was a really good discussion. Thank you all for your contribution. I think that as I mentioned that, well, there's really like a huge innovation potential when there are this policy push and a market pull. So actually that's really, really good. So there's a lot of possibilities in the textile waste recycling, and what Dolly was already pointing out that, well, there are certain regulations coming, especially the extended producer responsibility, which really also changes our understanding what is the waste and what's the value of the waste. That waste is really part of the business, and somehow we have to handle the waste. Also pointing, I think that it was Josse who was saying that we have to try to avoid exporting our waste to other countries. We really should somehow have the understanding and infrastructure how we handle these issues in the EU level. So I think that that's something really important, that we are always not exporting our waste problems or other kind of problems to other countries. That this is also innovation possibility here in EU level. And of course, the consumer side is really the one big challenge. Not only that how we design and produce longer lasting garments, but how we also invite consumers to change their consumption habits and use garments longer time, buy less, and then teach them how to then recycle garments right way at the end of their lifetime. So that of course is a quite big challenge for everyone. But Dolly pointed out that there are also business opportunities. I think that your figures show that there are so much waste that could be brought back to the industrial processes. So that's of course is interesting that there are these materials. We just have to scale up the technologies, and as Josse was already pointing out that there are emerging technologies, many of those ones, as well as Paula was pointing out that a lot of things are happening. Quite many of those technologies are in this scaling up phase. So coming from this lab scale to more like pilot, or even what Paula was saying, this kind of really like big industrial production. So of course that's really, really good opportunities to build totally new kind of textile and garment industry, even in European Union level. There were some specific technical questions, but perhaps I first like to ask that, and of course there's a lot of designers now listening to these webinars, and I think that there was good points that actually a lot of these things actually will change also the designers' work, that what kind of information actually designers need to have, and Paula was already pointing out that what is the feedstock that you want to have, for example, what to avoid, and I think that Josse was also saying something, but I think that there was one question linking to that, but yes, what are Josse cure feedstock requirements and priorities for feedstock sorting? Do you have any answer for this?
Yeah, no, I can share that, and that's of course a developing field. We're getting it more and more accurate in our pilot plant. But if you look from a textile point of view, we say to our brand sponsors also, initially we will look at post-industrial waste, very clear. There's also good for everybody to understand, one of our shareholder is IKEA. So we have access to relatively large volumes of post-industrial waste. Then we will look at what we call closed loop collaboration. So we work together with Auping, a Dutch mattress company. We know the bill of materials, they collect it back in a certain way, so we know we can trust the feedstock. The logic behind these two initial feedstocks are that the current collecting and sorting technologies are simply not capable to deliver according to a spec that we can handle. Nevertheless, we do look also at pre-consumer waste, so unsold stocks. But then again, we need to know the composition. The ambition is, of course, to move to post-consumer waste as it is collected on the street in containers and whatever. But reality is at this moment that nobody can guarantee the chemical composition and can also not sort accordingly. And we would love to have our technology so robust that we can say, just throw in everything. But frankly, chemistry doesn't lie. You know, there's no magic. In the end, if you throw in garbage, it will be garbage. So we want to move from 1% recycling first. Let's go to 20, 30% based on the streams that are possible. In the meantime, we continue to innovate in our pilot plant and add additional technologies to make it more robust. So let's grow into this together. That's what we're saying. We have, of course, very detailed specs being built up, as I showed you, but that's more for detailed discussions based on actual feedstock cases.
So basically, there are a lot of materials, but it's not so easy to handle in a sorting phase that what actually is the content of the fibers, as well as then what's the quality of the textile waste. That's also quite interesting. That even if you are talking about textile waste, we also need this kind of quality aspect in there. That what is still easy to recycle and what kind of materials you can get out. And of course, we are now talking about this upscaling, really like closing the loop and recycling fibers to new fibers. Of course, there are other kind of paths, also possibilities. For example, in composite sector, that actually all textile waste will not end up to this high level new yarns again. Might be that most of them, or quite big part of, actually will end up to downcycling and for example in the composite sector. But from Dolly, actually, I would like to ask about this policy aspect. And do you have any opinions that could policy somehow help to avoid this greenwashing? Because of course that's one of those big discussion points in this sector, that that a lot of these kind of like statements might not be quite correct or might not be based on scientific information. But what's your view for that? What kind of regulation especially could help in this manner?
Yeah, I think the work that's being done around the Green Claims Directive is definitely one that I would say is trying to tackle that issue of greenwashing and sort of unfounded claims around, the sustainability, and both from an environmental and social angle. So the Green Claims Directive is going to really be key in determining how you can claim product sustainability, whether that's about carbon neutrality, about it being environmentally friendly, about social responsibility as well. But I think a tool that's being prepared right now by the European Commission is the product environmental footprint, and that's really looking at the LCA impact methodology and quantification of that, which I think is such a big challenge within the industry in terms of being able to collect data about environmental impact. So it's I'm very curious. I think the work is a long-awaited one, with the PEF slightly delayed over the years, and I think it's coming up in the next year or so, hopefully, which is trying to create the standardized methodology and a tool for the industry to use to have comparable LCAs, and that can then be verified as well. So I think the Green Claims Directive, product environmental footprint are very key in that, but it also is down to both brands and retailers working together with third-party verification schemes to verify that the claims that they are indeed making are backed by data, right? So it's also all about having that data in check, having data systems that are digital, that are connected to one another within their supply chain, so that when these third-party verification schemes do come into place, there's a way for them to actually verify that the claims are correct. So lots of different players are involved, and I think there's still a lot of questions about how it's going to be implemented, and that's really going to determine its effectiveness as well. So definitely a space to watch, and one that we're also providing feedback on to the European Commission from the Policy Hub angle too. So yeah.
Thank you. So, and then I would actually like to point out, well, you also mentioned that you would like to see this kind of local small plants that they are close where the consumers are, which actually I like this vision that actually we can have more also local plants or factories who are handle this. But Paul had totally different kind of view that you have the Kemi factory now coming at the north part of Finland, so that will be a big one. So probably that will be the only one in the whole Finland. But how do you see, what's your future's view? And this I would like to ask from yourself as well as for Paula, that what will happen in 2 years' time, especially now when all these new technologies are so fast, they are emerging. I think that the development is really rapid currently, what is happening. Of course, that also depends from the investment side, that will these new technologies get the money that actually is needed to scale up? But what is your view? What will happen in 2 years' time? Perhaps Josse, you can start.
Yeah, it's a couple of questions mixed, Kirsi. So one is what will happen in 2 years' time, what will happen with the investment? So first of all, we see for the Cure technology, we don't need so massive investments. Yeah, one plant is around 35 million euro. And we do see that at least for the first one, which is to move from TRL 7 to TRL 8, we do get sufficient support. We're currently waiting for some feedback on some key subsidies from the Dutch government, also from the EU. But we already have letters of intent for more than the initial investment. Mind you, we can handle packaging and textile. So what you will see is that we can fund part of the growth into textile also by the more mature recycling of packaging. So we will be able to earn money with packaging and invest it in R&D for textile as well. So beyond, I think the bigger challenge is not the first plants and the rapid development in the next 2 years. I think what is much more exciting, what will happen in the 5 years after that, and do we really manage to scale and implement it in the Asian supply chains that are used by all the brands. And that's where Adidas is really coaching us and helping us to make sure we don't end with a Cure 1 plant, but with a Cure 2, 3, 4, and 5 plant, let's say. And that's where I think the real challenge will be.
Okay, thank you. And Paula, do you want to comment also this?
Yeah, I might be a bit of a party pooper here, but I'd say 2 years is a very short time when you're thinking of the time span of starting a plant. So if you think of just an environmental permitting process as a minimum of 1 year, if somebody complains, it's much longer. I think there's things happening in 2 years, but I think we have to look on a longer time span to see big changes. And I think what's really important now is for several of the players in this field to succeed so that the market starts believing in this. It's bad news for us if one of these competitors or so we say wouldn't pull through, because that just takes belief off the investors market. So that's really important, that we kind of push through together, and also we see that the EU is setting really, really strict sort of demands and goals for the green transition, but they're also offering a lot of support when you compare to non-EU countries. So it's kind of a situation where we have to deliver, but we're also getting support. But we do see as a small company that this kind of first large investment, there's maybe the instrument is still kind of lacking of finding like a large investment support from society.
Thank you. Okay, there's Alba asking, I was just wondering from the newer designer perspective, if Infinity Fibre had any type of sponsorship or collaboration programs for smaller collections, limited productions or prototyping. That is actually quite good question, because very often, especially in Finland, we have many new type of fiber technologies ongoing currently, but then there's this kind of fear that, well, will the Finnish companies which are small or medium size, will they actually drop out from this competition, that they're not bigger enough for this collaboration? But Paula, do you want to comment on this?
Yeah, so we do collaborations with smaller companies, are working with several Finnish companies. Currently, the thing is that our production is very limited at the pilot scale, and the companies who have invested in us are, of course, first on the list. And also the thing is that we just deliver fibers. So we are a company delivering fibers. Many designers may want to buy fabrics from us, and we don't supply fabrics. So right now we are kind of restricted to the low production levels, but I believe that when we transfer to the larger industrial plant, it will be easier. But it's always possible to contact us and suggest for collaborations.
Yes, and perhaps I can add here. So we have been collaborating with Paula also in this new cotton project, and there, for example, it's really important that they are real brands. They know the end users, for example, and what kind of like quality levels and what kind of attributes are really important for the end users. So in that sense, it's really important that actually there are big brands who can actually provide also information and feedback enough for the fiber development. So that's really important from this development point of view, so that bigger brands have a bit more resources to invest also in this kind of research collaboration. Okay, there's also a question for Jos, and that's that which year actually you expect cure in production scale. So actually somebody's asking about this kind of development, that how fast actually you are in this stage of your technical development that it's already in this production scale. What do you think about it?
So we hope by Christmas or latest in Q1 to announce the plant, the commercial plant. In fact, we are currently finishing the environmental permit request, et cetera, funding, aiming to open it in summer 25.
Okay, great. Sounds really good. Okay, perhaps the last questions for Dolly. I think that our time is up. So what's your point, Dolly, that actually what the EU regulations now, of course, everyone is waiting for the 2025 when the textile waste recycling will start in full scale. So what do you think that what will happen in 2 years' time? Do you see that because of course we are still on the way to construct the infrastructure, and might be that all the countries are not in the same phase in 2 years' time, that some are a little bit more advanced and prepared for this change. So how long does it take that we are actually, everything will be up and running smoothly? We have infrastructure, we are capable of collecting all the materials and putting that in the effective recycling path. So what's your viewpoint for this?
Yeah, I think 2 years is definitely too short of a time frame. So completely agree with Paula when she said that earlier as well. I think there's going to be a lot of changes definitely coming from the industry side. And we are seeing some EU regulations like the harmonizing separate waste collection, changes in the EPR and so on. But that's also, I think 2 years is just too short of a time frame to see very radical changes with regards to the infrastructure and how quickly the technology is also scaling. I think the technology is scaling, but again, setting up these facilities are very large capex heavy setups that need a lot of investment and a lot of R&D, and 2 years is definitely not enough. But I think as long as the infrastructure is starting to be built up and the investments in R&D are going into the places where business case is proven and where it's profitable, I think that's sort of where we need to focus the efforts in the next 2 years. And I think another point that was made, I think by Josse as well, there's lots of different important legislation coming up, all with different timelines. So it's really about aligning those and making sure that there's a harmony between all these different documents that are coming up. Sure, there's the green claims, there's the EPR, there's the waste shipments and everything, and the eco design, which all are kind of waiting on one another to develop. So how long do we have to wait before sort of targets and criteria are set up, right? So it's also about aligning those, and I think really moving forward. And all these phased implementations, you can give a lot of time for change, but I think there's also a moment when strict timelines need to be set up. So
Thanks. Yes, that's really important. And what we have learned from this kind of like different kind of projects and this kind of different kind of collaboration is really important that we have this kind of projects ongoing, which actually enhances the development quite fast, as well as there's a lot of this kind of sharing and openness and also learning from each other. I think that this kind of open collaboration is really important, that we really have to make the change together. It's not possible to do that by one stakeholder alone. And of course, it's really important that there are technology which are on this kind of scaling up phase, so that actually also get in the investments. So that's really important part of the story. Okay, I think that we are ready. We will end the discussion. I want to thank Paula, Josse, and Dolly. It was really, really insightful and knowledgeful conversation. So thanks everyone, and thanks for the audience. It was really nice discussion. Thank you, everyone.
Thank you. Bye-bye.
Thank you. Bye.
Great day. Bye-bye.